Finding the coefficient of friction of a block. Let's diagram our setup. We made a pulley system with a hanging mass that would fall and drag the block to the right. This experiment has two parts, when the mass is dragging the block and when the block is moving because of its kinetic energy on its own after the mass hits the ground. Here's the energy before and after diagram for the first part. Remember, we're dealing with the system. The initial gravitational energy comes from the hanging mass, and it gets converted into kinetic energy for both the block and the mass. The m and 1/2 mv squared is the sum of both objects' masses. Now let's look at the energy diagram for the second stage. The block has an initial kinetic energy, which runs out when it stops. Let's look at the experiment.
Like in all physics problems, let's draw a free body diagram. Let's start with the system. Since we're looking at the system as a whole, the force of tension is not considered. Once we isolate block 1, we have to consider tension as a force in our diagram. Since we're taking an energy-based approach to the problem, we have to look at the work done by non-conservative forces on each block. The work done by a non-conservative force is the final energy minus the initial. In the first part, we take the final kinetic energy and subtract the initial gravitational potential energy. Additionally, the work done in the second part is the work done by the frictional force, which is the difference in kinetic energy. Remember, the angle between the force and displacement is 180 degrees, so we can eliminate cosine theta as -1. Thus, we can solve for v squared and plug this back into our equation. Using our value for v squared, we can solve for the frictional force. Now, let's look at the forces acting on block 1. We know that the forces in the y direction cancel out because the acceleration in the y direction is 0. Therefore, the force of gravity is equal to the normal force. Additionally, we know that the force of kinetic friction is equal to the coefficient of kinetic friction multiplied by the normal force. Using this fact, we can use the expression for the force of kinetic friction that we found earlier to solve for the coefficient of kinetic friction. In our experiment, we calculated and measured the following values. d1 is the height from which block 2 falls. d total is the total distance traveled by block 1. d2 is the difference between the two and represents the distance block 1 travels after block 2 hits the ground. After plugging these values into our expression for the coefficient of kinetic friction, we get 0.398 as our answer.